Hi, welcome back to the channel. In this video, I'm going to focus on the discussion on Cambridge International AS Physics, Paper 1, Multiple Choice, which is February-March 2024, Paper 1-2. Get ready? Let us get started. Now, the first question, right? Which row shows a physical quantity and its base unit in the SI system? Now, first of all, you have to recall, right? What are the base units that required in your syllabus? There are altogether 6 base units that are required in your syllabus. Now, let me refresh you a little bit. Now, the first base unit, okay, let me choose a pen. Base unit and their physical quantity. These are base quantity. Now, the first base unit that is required in your syllabus is meter. The base quantity is length. Second, Kelvin. Base unit is Kelvin. The base quantity is temperature. Third, second. The base unit is second. That the base quantity is time. Fourth, ampere. The base unit is ampere. The base quantity is electric current. Mole. 1, 2, 3, 4. The fifth is mole. The base quantity is amount of substance. And the last one, kilogram, the base unit. That is the base quantity is mass. So you are required to memorize all these 6 base quantities together with their base unit. Now, let me answer the question, the first one, right? Quantity current, the base unit is ampere. This is correct. Now, let us check B, C, and D to prove that B, C, and D are wrong. Force is not force is a quantity, but the base unit of force, you remember force, F equals ma. So you can only use meter, Kelvin, second, ampere, mole, or kilogram, right, to represent the base units. So force, okay, I am going to break it down. Mass is measured in kilogram. Acceleration, now I have to write here, acceleration is defined as the rate of change of velocity. Velocity is meter per second divided by time, that is meter per second square. So this is the base unit of force, kilogram meter per second square. Mass, the base unit of mass is kilogram, not gram. So this is wrong. The temperature, the base unit of temperature is Kelvin, not degrees Celsius. Therefore, the answer is A. Number 2, a car of mass 850 kilograms is traveling in a horizontal straight line. Diagram shows the 2 horizontal forces acting on the car in the opposite directions. One force has a magnitude of 1,200 Newton and the other force has a magnitude of 1,600 Newton. What is the magnitude of the acceleration of the car? When you see the word acceleration, first of all, see the word acceleration, you have to remember, you have to find the value of the resultant force because resultant force gives rise to acceleration. F equals to ma. That's the equation that I'm going to use for this question. Right, F represents resultant force. So do you should remember force is a vector quantity. One force is forward, the other force is acting in the opposite direction. Question has already given you the hint. Since the force is a vector quantity, you have to use the direction. Vector means a quantity which is, right, not about the magnitude, but also about the direction. Right? One direction is considered as positive, the other direction has to be considered as negative. Right, so I will consider the larger force to be positive, to the left to be positive, therefore to the right would take a negative value. So the resultant force is 1,600 plus negative. Resultant force is the sum of all the forces that are acting on one object. So I plus negative the direction equals to the mass of the car, which is 850, and the acceleration is the one that I have to find. 1,600 minus 1,200, that is 400, which is equal to 850 ampere, not ampere, sorry, A. Acceleration, A is equal to 400 divided by 850. You should end up getting 0.47 meter per second square. So the answer is A. Number 3, an object of mass m is suspended by a spring from a fixed point. The spring has a spring constant k. The object is set into vertical oscillation up and down of period t. Which equation for t is homogeneous with respect to base units? Now, you have to remember, what does it mean by homogeneous equation? Homogeneous equation means that the left-hand side base units must be equal to the right-hand side base units. That equation is called homogeneous equation. Right, so we have to look at the equation one by one. So what is, okay, this is period. Period means time. The standard international unit or the base unit of period is second. Left-hand side is second, right? Okay, so I have to do for A first. Left-hand side is second. Right-hand side. RHS means right-hand side. 2 is a number, there's no unit. Pi is a number, there's no unit. Now we have to determine a unit of K. So you remember the Hooke's law? I have to write here. So this is about the spring. With the spring constant, you have to recall your Hooke's law. Hooke's law, F equals Kx, if you still remember. F, the unit, the standard, okay, or the base unit of F is kilogram meter per second square. K, X is the extension, so the base unit of extension is meter. K is equal to kilogram meter per second square divided by meter. So the unit of spring constant is kilogram per second square. So right hand side, I have to sub it in. I'm going to use the blue color for the right hand side, and the left hand side, I'm going to use black color so that you can identify easily. So right hand side, it is K, which is kilogram per second square divided by meter. Right hand side, I got kilogram per meter per second square. So A is not your answer because left hand side is only a second. It is not equal to the base units on the right hand side. So A cannot be the answer. What about B? Okay, right hand side. Because left hand side, I already know the unit of T, which is S. Right? I need to focus on my right hand side equations and simplify the units in terms of base units and get second. Now B, right hand side. M is measured in kilogram. K is kilogram per second square. So kilogram and kilogram you cancel off. So you get second square. Now B cannot be your answer because the answer is second square. I need second. Right. C, right hand side. K, square root, yeah. This is a square root. K is kilogram per second square. M is kilogram. So square root, kilogram and kilogram, you can just cancel off. Square root of S to the power of negative 2 per second square. So you get S to the power of negative 1. That is also not true because I need to get second on my right-hand side. Now D is our only hope, right? So D, right-hand side, kilogram divided by kilogram per second square. So kilogram and kilogram just cancel off. Second square, you move outwards. It becomes second to the power of negative 2. You move outwards per second square. You square root it. You get second. So left-hand side unit is equal to the right-hand side unit. D is a homogeneous equation. D is the answer. Number 4, an object of fixed mass is initially at rest. When I see the word initially at rest, I straight away put U equal to 0 at point P. The object then moves away from point P with uniform acceleration. Uniform acceleration means constant acceleration. Which statement describes the resultant force acting on the object when it is moving? So remember, F is directly proportional to acceleration. F means resultant force. Right? When the acceleration is uniform, the resultant force must be uniform as well. So it cannot increase uniformly. It has to be uniform. B, it is constant. Uniform means constant. Yes, and it is not 0. B is the answer. Let us prove C and D are wrong. It is proportional to the displacement, not proportional. It is 0, not possible because there is an acceleration. Right? So B is the answer. Number 5, a projectile is launched at an angle of 25 degrees to the horizontal with a horizontal component of velocity of 13 meter per second. So I better draw this out so that you can see it. So this is the projectile. This is the velocity. I just put V. Angle, this is 25 degrees. And they told you, I make a careless mistake for this question, so I want you to repeat my careless mistake. Horizontal component, this is the velocity of 13 meter per second. Remember. So they ask you, what is the vertical component, Vy, of the velocity of projectile when it is launched, right? So you see, this is about x and y. I'm going to use opposite over adjacent. I'm going to use tangent. 25. Opposite is Vy divided by 13. So Vy is equal to 13 tangent 25. Just use your calculator. You should be able to get 6.1 meter per second. B is the answer, remember. Question number 6. A ball is released from rest at position X at time 0. At 1 second, it bounces inelastically. Inelastically meaning to say that the kinetic energies, initial and final kinetic energies, are not the same, right? From a horizontal surface and rebounds, reaching the top of its first bounce at 1.5 seconds. What is the total displacement of the ball from its original position X at time at 1.5 seconds? So look at the graph. This is a graph of velocity against time. How do you find the displacement from the graph? Remember, when a graph is being given, there are two information that you could obtain from the graph. One is the gradient of the graph. The other one is the area under the graph. To find the displacement, you need area under the graph. So I'm going to find these two area, right? Because displacement, and you have to bear in mind, displacement is a vector quantity. Therefore, directions are very important. So if the value of velocity is negative, you have to put in negative, right? So I'm just finding this area. This area would be half times width, which is 1, times the height, which is 10. So I got 5 meter. And then after that, I'm finding the area of this one. Area 1 and area 2. Is that okay? So it is half 1.5 minus 1. You should be able to get 0.5. This is the length of it, the width of it, and the height is negative 5. Remember, displacement is a vector quantity, so you have to put in the negative value. And I got negative 1.25 meter. Total displacement, total means the sum, the addition of two displacements. So total displacements is equal to A1 plus A2, which is equal to 5 meter plus negative 1.25 meter. So the answer is 3.75 meter. The answer is B. Now, question number 7. What is the definition of acceleration? Remember, each and every physical quantity that you learn in physics has only one definition. Let us look at it. Change in velocity per time. That is true, but I just want to keep on looking at B, C, and D. Rate of change of speed. Rate of change of speed. No, it is velocity because acceleration is a vector quantity. It depends on velocity, not speed. That is wrong. C, rate of change of velocity per time. That means rate means change of velocity per time divided by time because rate means per time. So twice, right? 2 times double divided by time. So that is also wrong. Resultant force per unit mass. No, that is not the definition. See that? That is not the definition. Even though the equation, right, we use F equal to ma, right? But that is not the definition of acceleration. That is another expression for acceleration. Therefore, the answer is A. Number 8, two balls, P and Q, of equal mass. Equal mass, this is very important. equal mass move along a straight line directly towards each other as shown. Ball P has a velocity of 1.3 meter per second to the right. Ball Q has a velocity of 0.5 meter per second to the left. P and Q collide with one another. The collision is perfectly elastic and the total momentum is conserved. Which diagram correctly shows the motion of P and Q after the collision? I know, right? When the question talks about the perfectly elastic collision, first of all, you have to remember, right? There are characteristics that needs to fulfill in order to get a perfectly elastic collision. First one, total momentum before the collision must be equal to the total momentum after the collision. That is one condition. Okay, total, I just write it here, momentum before, okay, equals total momentum after. Right, that's the first one. Second, perfectly elastic collision also means that total kinetic energy before the collision equals total kinetic energy after collision. And due to the combination of the conservation of momentum and the conservation of kinetic energy, we get another expression for perfectly elastic collision, which is relative speed of approaching equals relative speed of separation. But I'm not going to do that because this is paper one. This is not paper two. Paper one, you have limited time. So I'm going to teach you shortcut. You see the word, you have to find the keyword first. The keyword is perfectly elastic collision. Whenever you see the perfectly elastic collision, okay, I will just use the third expression here. Relative speed of approaching, relative speed of approaching. Okay, I just want to find my relative speed of approaching. Some of you might say that, oh, you want to find out your relative speed of approaching? You have to form an equation using the total momentum before equals total momentum after. And then you combine with another expression, which is total kinetic energy before the collision equals to the total kinetic energy after the collision, right? That is a waste of time. That is like, it requires a lot of time and I might be making a lot of careless mistakes. So I'm not going to do that. I'm going to teach you shortcut, right? If this question appear in your paper one, first thing you do, okay, find the relative speed of approaching. Speed of approaching, how do you see it? I teach you shortcut on how to see it, right? So I'm going to use a different color here. Look at P. P is going towards Q. Q is going towards P. Can't you see that the directions of the velocities of P and Q are opposite to each other? If the two directions of the velocity are opposite to each other, you just add up their velocity, add up their speed. So 1.3 plus 0.5. So I got here 1.8 meter per second. Opposite direction, just add. Okay, now relative speed of approaching must always be equal to relative speed of separation, right? You look at A. Look at A. Let us do A. A, P is towards right. Q is also towards right. P and Q are acting in the same direction. I mean, the velocity of P and Q are right in the same direction. So in the same direction, you take the large value minus the smaller value. This is relative speed of separation. So 0.58 minus 0.22, you're supposed to get 0.36. Could you see? I get 0.36 meter per second right here. It's not equal to 1.8. So A cannot be your answer. B, it seems like P and Q are sticking to each other, move together in the same direction and stick to each other. That is not elastic collision. C, okay, look at the direction again. Look at the direction of P. Look at the direction of Q, right? So P and Q. P is towards right, Q is towards left. Oh, opposite direction. So opposite direction, the relative speed of separation is equal to, you just add them out, 0.19 plus 0.99. That gives you 1.18 meter per second. C cannot be your answer as well because I want 1.8, no 1.18. And let us look at D. P is to the left, Q is to the right, opposite direction, right? They are moving in opposite direction. So the relative speed of separation is equal to 0.5 plus 1.3. So I get 1.8 meter per second. Can you see? Ta-da! D is the answer. Now, number 9, a basketball player hits the ball vertically downwards with a speed of 2.4 meter per second from a height of 0.9 meter. Air resistance is negligible. This is a good news. Air resistance is negligible. I'm going to draw the whole situation right here, before I do it. So this is a basketball, and then the height is 0.9 meter, and then going downwards. Okay, going downwards with 2.4 meter per second. Air resistance is negligible. What is the speed of the ball hitting the ground, right? For this case, I'm going to use one of the kinematics equation, which is V square. Okay, there are 3 kinematics equation, right? There are 3 kinematics equations. So the first one, okay, I'm going to use S equal to UT plus half GT square. V square equal to U square plus 2GS. V is equal to U plus GT. When you see vertically downwards, the A, you convert to G. Right, so I am going to use the second expression because I cannot use the first and the third expression as the time is not given. So I'm going to use V square is equal to U square plus 2GS. Now, the V square, the speed, is the one that I need to find. U square, 2.4, you square it. And then plus 2G, negative 9.8. And, okay, if you want to put, you see, right? I need to explain this to you. I know that V is downwards. If you consider the direction downwards as positive, G will take a positive value. G is 9.81 meter per second square. But the height is measured from the ground upwards. So the height would take a negative value, right? Remember that. G is 9.81 and then height is negative 0.9. So you work it out. You are supposed to get, square root the answer, you are supposed to get 4.84 meter per second. The answer is B. Question number 10, a ball falls through a liquid at constant speed. It is acted upon by 3 forces: upthrust, drag force, and its weight. Liquid has a uniform density. Okay, which statement is correct? This is a ball, and then weight is acting downwards, going down. And then there's a drag force. This is a drag force. FD represents drag force, and upthrust, U. Right? So the statement, one of the statements states that the liquid has a uniform density. This has something to do with upthrust force. Upthrust force is equal to rho Vg. Density of the liquid is constant, meaning to say that the upthrust force is constant. Right? Density, constant, upthrust, constant. Remember that because upthrust is the one that we can relate to the density. Now, let us read the correct statement. Let us find the correct statement. Number 1, the drag force increases with increasing drag. No. The one that, increases with the increasing depth is the pressure. Right. B, the drag force is equal to the sum of upthrust and weight. No, weight is equal to drag force plus upthrust. That is wrong. Yeah. C, the upthrust is constant with increasing depth. This sounds correct, but I look at D, weight is greater than the sum. No, weight cannot be greater than the sum of drag force and upthrust. Why? Because the ball falls with a constant speed, meaning to say that the resultant force acting on the ball is equal to 0. So all the forces must be balanced, cannot be greater than the others, right? So the answer is C. Now, number 11. Number 11 seems to be a little bit of complication here, a bit complicated. I'm going to do it down here later because I don't have space here. Number 11, some small solid cubes, each have mass 1 kilogram and size of length 5 cm. These small cubes are stacked together to form a large solid cube with size of length 2 meter. What is the weight of the large cube? You know why they give you the length? Okay, I'm going to do number 11 right here. Easier for me to do it. Number 11, I have a small cube. Wow, this is just a small cube. And then the length of the small cube. Wait, let me see. The length. Side length 5 cm. I'm going to put into a standard unit, which is 0.05. Is that okay? 0.05 meter. And the mass is 1 kilogram. From here, right? Because they're talking about the same cubes, I'm going to find the density. Right? Density is equal to mass over volume. Right, so the density of this cube, mass of this cube is 1 kilogram and the volume is 0.05. You cube it. They have already told you this is a cube, right? A cube has the same side length. Therefore, okay, you're supposed to get 8,000 kilogram per meter cube. And then all these cubes are stacked together, right? With, I don't know how many of them, right? Because they said they're stacked together to form a large cube, right? With the side. Okay, they told us the side. So stacked together, okay, just imagine that all these cubes are stacked together. Okay, they are being stacked together to form a larger cube, right? Of side length 2 meter. So I just want you to remember because they are of the same cube, right? Same cube, one density, right? So density, I just put density, mass over volume. I just need to find the mass of the large cubes when they are being stacked together. Density is still the same, which is 8,000. Mass, but the volume will be different, right? 2, you cube it. So the mass of the large cube stacked together would be equal to 8,000 times 2 to the power of 3, or 2 cube is 8. So you get 64,000 kilograms. Now look at the question. They ask you what is the weight. Since I got the mass, very easy for me to find the weight, don't you think so? W is equal to mg. 64,000 times 9.81. So you're supposed to get 0.628 times 10 to the power of 6 Newton or 0.63 mega Newton. C is the answer. Number 12, a borehole of depth 2,000 meter contains both oil and water as shown. Pressure due to the liquids at the bottom of the borehole is 17.5 megapascal. Density of the oil is 830 kilogram per meter cube and the density of the water is 1,000 kilogram per meter cube. The question asks, what is the depth X? Now, since the densities are being given, right? So what do I do is that, they give us the pressure, the total pressure due to the liquid at the bottom of the borehole. This is the total pressure. Pressure total is equal to 17.5 mega. I just put 10 to the power 6 Pascal. Is that okay? Now, total pressure, remember, total pressure is the pressure of the oil plus the pressure of the water. Total pressure is equal to pressure of the oil. Remember, there's another expression of the pressure of the liquid, which is density oil, G, times the height of the oil, plus density of the water, times G times height of the water. So now simplify 17.5 times 10 to the power 6, density of the oil, which is 830 times 9.81 times the height of the oil, which is X. I just put X, right? Plus, I just put here plus density of the water, 1000 times 9.81 times 2000 minus X. Is that okay? Because I want to get this, right? This is the whole length is 2000 meters. So 2000 minus X, that is the height of the water. Now we have to simplify this a little bit. So 17.5 times 10 to the power 6 equal to, I do it one by one. I open out the bracket. So 830 times 9.81 times X, I get 8142.3X plus 19.62 times 10 to the power 6 minus 9810x, right? Simplify, make x the subject. X is equal to 1270 meter. D is the answer. Now, number 13. A rod is pivoted at one end. Initially, the angle theta of the rod to the horizontal is 0. Okay, I draw the rod. This is a rod. This is the pivot. The weight of the rod causes a moment. This is the weight of the rod. Weight causes a moment m about the pivot. The rod is then rotated. Okay, start from 0 angle, rotated 180 degrees, right? So keep on moving the rod till the rod will move like this. Can you see that? Okay, so you got to get the theta here. Could you see that? So do you still remember how do we calculate the moment? Moment is equal to the force, which is the weight, times the perpendicular distance. Now, the perpendicular distance, weight is vertical. You want to find the perpendicular distance, you have to find the horizontal distance from the weight, right? Which is equal to adjacent. Yeah. So I put d cos theta. So it is actually cos theta, right? So the graph, right, of the theta cannot be A because theta varies. Therefore, the moment will change as well, right? So the moment, okay, remember the cos graph. Whenever you plot a cos graph, cos theta, and then this is time. Cos graph is like that. So you start from a certain value. So could be B, could be D, but it cannot be C. Right, and then I have to check again. Okay, until 180 degrees. Can you see that? When 180 degrees, that means the rod is now at the opposite direction. Could you see that? This is 180 degrees. 180 degrees. I want you to see this. Weight is acting at the opposite direction and the pivot is on the left-hand side. Initially at 0 degrees, pivot is on the left-hand side. Now, after 180 degrees, pivot is on the right-hand side. Can you see? Moment. The direction of moment has changed. Right, so that is why you have to give a negative value to it, the moment. So this is positive value at 0 degree. At 180 degrees, it needs to have a negative value. That is why D is the answer. Now, question number 40, repeated question. A hinge trap door is held close to in the horizontal position or by a cable. Three forces act on the trap door: the weight of the door, the tension and the cable, and the force H at the hinge. Now, which list gives the three forces in increasing magnitude? Okay, I want you to look at tension. Could you see that tension can be resolved into horizontal and vertical, T horizontal. Even same goes to H, can be resolved into horizontal, H horizontal, and H vertical. But weight is acting in vertical direction. It cannot be resolved, right? So weight appears to be the smallest one because it cannot be resolved, right? Say no to A or B. Now, compare between T, tension, and hinge, right? First of all, look at tension vertical. Tension vertical is acting outwards, but the H vertical is acting downwards. So tension vertical is equal to weight plus H vertical. Could you see that the value of tension is larger than H? Because H has to act with weight to get tension. So tension is the largest one, H, okay? After W, smallest one, followed by H, and then T. C is the answer. Number 15, what is the definition of force? If you recall Newton's second law, the definition of force, right? How Newton's defined force is the rate of change of momentum. C is the answer. This is about the definition. Product of mass and acceleration. This is another expression of force. Mass and velocity, product of mass and velocity. This is momentum, nothing to do with the force. Rate of transfer of energy, energy transfer divided by time, rate divided by time, that is called power, right? Nothing to do with force. C is the answer. Number 16, a boat moves at constant velocity. I want you to remember constant velocity V through still water. A drag force F acts on the boat. What is the power used by the boat to move through the water? Power, still remember, power is equal to work done divided by time. Definition of work, work is equal to force times the distance moved in the direction of force. Sub into the equation, force, distance, move in the direction of force. Now I want you to see this, right? Only when the question mentioned that object is moving at constant velocity, right? You can use velocity is equal to displacement over time, or speed is equal to distance over time. This equation can only be used when the speed or velocity is constant. So I'm going to sub in P is equal to FV. That is why B is your answer. Number 17, the diagram shows 4 forces acting on a circular disc. Each force has a magnitude F. 2 of the forces act vertically and the other 2 forces act horizontally. All 4 forces act in the same plane as the disc. No other forces act on the disc. The disc has diameter D. Okay, diameter D and diameter D as well. So which statement is correct? Now, whenever you see this question, they ask you whether is this equilibrium or not equilibrium, right? Conditions for an object or for a system to be in equilibrium. First one, you have to check, right? Okay, wait, I write down first. First condition for the equilibrium is that resultant force must be equal to 0. Second condition is the resultant moment must also be equal to 0. But, okay, before that, okay, check this out. F and this F, okay, use different color. The other F, this F and the other F, which is this one. Okay, could you see that the 2 forces, okay, the F to the right and the F to the left, they are coupled. What do I mean by couple? Couple means that the 2 forces are acting in the opposite direction and they are of the same magnitudes and they are being separated by distance. Whenever you define and whenever you detect couple in the diagram given, right? So straight away put cross to equilibrium. System would never be equilibrium. Okay, now it is down to B and D. How do we get the exact answer? Moment, how do you find the moment of a couple? Moment of couple. Moment of couple, you just take one of the 2 forces, multiplies by perpendicular distance between the 2 forces. So it is FD for this moment. And the green force, okay, I have another moment. I have 2 moments of a couple. I have 2 couples here. So force, magnitude of one of the 2 forces multiplied by the perpendicular distance, FD. So the total moment is equal to FD plus FD to FD. So that is why the answer is D. Now, number 18, a ball is projected into the air from a horizontal ground and follows the path shown in the diagram. At points Q, R, S, and T, the ball has kinetic energies EQ. Here is EQ, ER, ES, and ET, respectively. The heights above the ground of these 4 points are shown. Air resistance is negligible. Another good news here. Okay, ignore air resistance. Which difference in kinetic energies is the smallest? They're giving you hints, the height, right? So since the air resistance is negligible, so I'm going to use the principle of conservation of energy. That means the total change in gravitational potential energy is equal to the change in kinetic energy. I want the smallest difference in the kinetic energy. Gravitational potential energy is mg delta h. So the height must have the smallest. The change in height must be the smallest in order for me to get the smallest change in gravitational potential and in kinetic energy. So let us look at EQ. EQ and ES, right? EQ and ES. Okay, I use different color so that you can see it. So EQ is 1.6 meter. ES is 1.6 meter. EQ is 1.5 meter. No problem. Take a big value minus a small value. So you get 0.1 meter. ES and ER. ES is 1.6. ER is 1.8. So 1.8 meter minus 1.6 meter. So you get 0.2 meter. ET and EQ. ET is 1.3. EQ is 1.5. So 1.5 meter minus 1.3 meter. You get 0.2 meter as well. ET and ER. ER is 1.8 meter. ET is 1.3 meter. So you get 0.5 meter. So the smallest change in height is A. So that is why A will give you the smallest difference in kinetic energies. Right. Number 19. The battery of a small tablet computer is initially uncharged. It is connected to a constant 10-watt power supply for 2 hours to change the battery. The efficiency of the charging process is 80%. What is the total energy stored in the battery? So do you still remember efficiency? Efficiency is equal total energy. So I'm going to use the useful energy output divided by the input energy times 100%. So whatever I have, I'm going to sub it in first, 80%. Energy output, they give me power, they give me the time. So energy, do you remember? Energy is equal to power times time. So energy output is equal to output power, 10 times time. Time must be in second because the energy must be measured in joules. So you have to change your 2 hours to second times 60 times 60. So here you will get 72,000 joules. So sub in 72,000 joules divided by input energy, which I'm supposed to find, times 100%. Work it out. The input energy is equal to 72,000 times 100% divided by 80. So you are supposed to get 5.76 times 10 to the power of 4 joules. 5.76 rounded off to 5.8 joules. Now, question number 20, I'm going to do it down here because there's a lack of space here. Number 20, let me read the question first. An initially stationary firework explodes and splits into 2 fragments that move horizontally in opposite direction. So here, initially stationary, split to 2 fragments, move in the opposite direction. One is M, the other one is 2M, right? Move in the opposite direction. So the total kinetic energy transferred is E, and one fragment has mass m, and the other one has a mass of 2m. What is the speed of the fragment of mass m immediately after the explosion? No worries, no worries. Let us do this together. So since I am supposed to find my total kinetic energy before is equal to total kinetic energy after. The total kinetic energy, okay, question number 20. So I'm going to use the total kinetic energy to do it. So, okay, E total is equal to E of mass m plus E of mass 2m. Is that okay? Because they are moving with speed. E total is E given half m, I put V1 square plus half 2m V2 square. Is that okay? Now, I try to simplify it. This is half m, okay, V1 square plus half 4m V2 square. So I have 2 different expression right here. So no worries, right? I am going to put this as equation 1. Use the principle of conservation of momentum. Momentum before is equal to zero because the big mass is initially stationary and exploded into two fragments moving in the opposite direction. Moving in the opposite direction. So I would say that mass m move with speed v. Mass 2m move with speed v1. Mass 2m move with speed v2. Can you see that they are moving in opposite directions? So I will consider one direction as positive, the other direction as negative. So I'm going to consider positive to 2m, negative to m. Yeah, v2 is positive, v1 is negative. So m v1, okay, and negative v1 because v1 I consider as negative. It doesn't matter which one you want to consider as negative. Negative v1 plus 2m v2. So since this is negative, I want to move to the left-hand side. m v1 is equal to 2m v2. You just cancel. So v1 is equal to 2v2, right? So I got that expression. So when I have this expression, so I can sub into the equation, right, to get my answer of the speed, right? So I get the kinetic energy first. So now, okay, 2. So sub 2 into equation 1. Right, E is equal to half, and V1 is 2V2, so 2V2 square. I'll write it nicely. M, this is 2V2, and then you square it, plus half 4M V2 square. Now, half M 4v2 square plus half 4m v2 square, right? So when you simplify, this is 2m v2 square plus 2m, right? 2, right? 2m v2 square. So I have 4m v2 square, right? Am I right? Let's see this. Okay, this is 2. I'm so sorry. This is 2. This is 2. Cannot be 4. Okay, see here. Okay, I accidentally put 4. I'm so sorry. Okay, this is why. Okay, this is 2. Yeah. Okay. I write it nicely. This is 2m. Just 2m. I square it, accidentally square it. So this is I just change it to 2. Remember? This is 2. This is 2. Okay, I redo everything. Don't worry. Okay, this is 2m, this is 2m, right? So simplify, this is 2m v2 square, 2m v2 square plus m v2 square. So I have 3m v2 square. And then to get the v2, okay, v2 is equal to e over 3m square rooted. Now I know that I need to get the mass of m. Okay, so V2, I got an expression. So sub into equation 2 into equation 2. Actually, you supposed to sub in V2. So V1, because I need to get the speed of V1. So 2e over 3m, right? So square the whole thing. Not squaring the whole thing, just square the 2 in order for you to put in 2 into the square root. So I square the 2, okay, so that I can put in 2 into that square root equation. So V1 is equal to square root 4e over 3m. So the answer is actually D. Yeah, you can sub in V2. You are supposed to sub in V2 in order for you to get V1 expressions right away, right? Now, 21, try to sub in V2 into the expression of 1. V2 into equation of 1. So you are supposed to get the answer right away in order, like, instead of like, again, to sub in into equation 2, right? That is tedious. Now, question number 21. A spring is fixed at one end and extended by applying force F to the other end. The spring has extension X and elastic potential energy EP. The spring constant is K. The spring obeys Hooke's law. What is the relationship? Which relationship is correct for this spring? So you remember elastic potential energy, this is equal to half kx squared or half fx. So let us see. The spring has extension. Okay, and elastic potential energy. Spring constant is X. Okay, I cannot say that the spring elastic potential energy is directly proportional to F because X is changing too. So I have to make sure that one is constant. If I have three unknowns, I have to make sure that one is constant in order for me to compare the two. Right, what about the first expression that I stated? EP is equal to half kx squared. I know k is constant because the spring has a constant spring constant. So that is why I can safely state that elastic potential energy is directly proportional to extension squared. So D is the answer. Number 22, a force extension graph is produced for a metal wire. What must describe the limit of proportionality of the wire? So if this is force against extension, maybe cm, right? Limit of proportionality is a point which beyond it, Hooke's law is no longer being obeyed. Now let us see the point at which the wire breaks. No, it is not limit of proportionality, right? It could be elastic limit. Yeah. B, the point beyond which Hooke's law is not obeyed. This is definitely true. B is the answer. Let us look at C. The point beyond which wire cannot return to its original length. This is called yield point or elastic limit. Elastic limit is where, right, is the point which exceeded, object would not return to its original dimension. U point is the point where plastic deformation starts. D, the point beyond which wire starts to deform plastically. This is called U point. This is better definition of U point. So I just put a U point here. U point is the point where plastic deformation starts. Right? 23. A spring has a spring constant of 6 Newton per cm. It is joined to another spring whose spring constant is 4 Newton per cm. A load of 80 Newton is suspended from this composite spring. Right? What is the extension of the composite spring? Now, spring constant, when the two springs are connected, this is called series, right? One end to another. This is called series connection. Series connection, how do you find your total spring constant? Total spring constant will be 1 over 6 plus 1 over 4 inverted. So the total spring constant is 2.4 Newton per cm. Now to find the extension, I have the force. F equals to kx. F is 80, k is 2.4, and x is just x. X is equal to 80 divide 2.4. You are supposed to get 33.3 cm. The answer is D. Number 24, the range of frequencies of sound wave emitted by blue whales is 10 Hz to 40 Hz. The speed of sound in seawater is approximately 1.5 kilometer per second. What is the approximate range of wavelengths of the sound waves emitted by blue whales? So to find the wavelength, right, do you still remember equation of wave? V equal to F lambda. So I find wavelength maximum first, which is V over F minimum. V is 1.5 kilometer. Kilometer, I want to change the meter. So I times 10 to the power of 3 divided by minimum F, which is 10. Right? So 1.5 times 10 to the power of 3 divided by 10. So I get 150 meter. And I find my lambda minimum because I need the range. V over F maximum. So V is 1.5 times 10 to the power of 3 divided by 40. So I get 37.5 meter. So which is within the range? D is the answer. Number 25, a sound wave is detected by the microphone and displayed on the screen of a cathode ray oscilloscope, CRO. Frequency of the wave is 2.5 kilohertz. What is the setting on the time base of the CRO? Since the frequency is being given, I have to find the period first because, right, from period, then only I can determine the time base. Right? Period is equal to 1 over frequency. So 1 over 2.5 kilo just times 10 to the power of 3. So the period is 4 times 10 to the power of 4 second. So I draw equilibrium position of this wave, and then I calculate how many waves, complete wavelength, complete period, yeah, here. Time taken for one complete oscillation. This is one wave I can form. And then I have two wave. Sorry. This is the second wave. And then I have the third one. Okay, not the third one, 2.5. So I can form 2.5 period here is equal to how many boxes involved? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 cm times the time base. So period, I got a value which is 4 times 10 to the power of -4 is equal to 10 cm times the time base. Therefore, the time base is equal to 2.5 times 4 times 10 to the power -4 divided by 10 cm. So I got 0.1 meters second per cm. Right? So A is the answer. 0.1 millisecond, not meter second, millisecond per cm. Yeah, try to do it. Number 26, a source of sound waves with constant frequency moves towards a stationary observer. The observer compares the sound wave arriving at the observer's position with the waves emitted by the source of the sound. What is detected by the observer? Sound wave, this is Doppler effect. Yeah, sound wave move towards, right? Sound wave move towards, frequency is actually observed frequency is increasing. So you remember the ambulance with the siren on moving towards you. So the frequency is increasing. When the frequency is increasing, V equals to F lambda, the speed of the wave is constant, right? So that is why frequency is inversely proportional to lambda. When the frequency is increasing, lambda is decreasing. So C is the answer. Number 27, which type of wave cannot be polarized? The only way, right, we can differentiate between transverse wave and longitudinal wave is by the process which we call it as polarization. Polarization is the cutting of the wave to make sure that the wave can travel in one direction only. Right? So the answer is sound wave. Sound wave already travel parallel to the direction of travel of the wave. Therefore, it cannot be polarized. B is the answer. Okay, 28. A beam of light with power P has an area of cross-section A. Amplitude of the light waves in the beam is X. The beam of light is then changed to one with same frequency but with an increased amplitude of 4X and an area of cross-section reduced to A over 3. What is the power in the new beam? Okay, I want you to remember intensity is directly proportional to amplitude square. Since the amplitude is given as x, so I put x squared. So to get rid of this proportionality, we put a constant times x. Okay, square, put x. Right? Intensity is also being defined as power per cross-section area. So I would just say that kx squared is equal to p over a. How about that? First, okay, this is my first expression. Now, intensity amplitude has been changed to 4x. So 4x, the whole thing you square, and then power over A over 3. Second equation, without the second equation first, I need to simplify this first. Okay, this is K 16x squared is equal to P A over 3. Second equation. So I use P over A as kx squared, right? Into, I sub in K. How about that? Okay, from 1, K is equal to P over AX squared into equation 2. So Kp over Ax squared, 16x squared is equal to P over A over 3. Now simplify x squared. So now 3 I times up. Okay, P and P, you just cancel it off. Now I have 16 over A is equal to 3 over A. Is that okay? 3 over A. Right? What is the power? Oh, this is a new power. I'm so sorry. Okay, power is different. Okay, I thought the power is the same. So this is a new power, yeah? I cannot just cancel it off. Okay, P new. Okay, here I have P new A over 3. Okay, 3P new. I just shift out the A. I just shift out the 3. 3P new over A. A and A you can just cancel off. So that is why P new is equal to 16 divided by 3. So it is 5.3 P, right? 5. Where is the P? P is here, yeah? So P. So 5.3 P is the answer. B is the answer. Question number 29. Two loudspeakers are connected to the same signal generator. Signal generator produces a single frequency. Loudspeakers face each other so that the stationary sound wave is set out in a region between the loudspeaker. So a microphone is connected to a cathode ray oscilloscope, CRO, and positioned between the two loudspeakers. The microphone is moved along the line joining the two loudspeakers. Signal on the CRO shows 5 maximum amplitudes as the microphone moves. The microphone moves a distance of 2 meters from the position that gives the first maximum to the position that gives the fifth maximum. This is very important. So what is the wavelength of the sound wave? This is stationary wave maximum. So you draw stationary wave first. Okay, like that. And then I'm going to use a different color to show you. Okay. Okay. So from the first maximum, 1, 2, 3, 4, 5. First maximum to the fifth maximum. Right? This is 2 meter. What is the wavelength? So you have to know that this is 1 over 2 lambda, 1 over 2 lambda, 1 over 2 lambda, 1 over 4 lambda, and this is 1 over 4 lambda. So 1 over 4 lambda plus 1 over 2 lambda plus 1 over 2 lambda plus 1 over 2 lambda plus 1 over 4 lambda is equal to 2 meter. 1, 2, 3. This is 4 over 2 lambda is equal to 2 meter. Lambda is equal to 2 meter times 2 over 4. So your lambda is 1 meter. The answer is D. Number 30. Two wave sources emit coherent waves. Which condition must be correct for the coherent wave? For the coherent wave, you have to bear in mind, right? So the two waves can have phase difference, right? But the phase difference must be constant. This must be correct. Okay. Yes, their emitted must be in phase because when they emit in phase, that is 100% coherent. They can also have phase difference, but the phase difference must be constant. That is the one that you need to make sure. Okay, number 31, a student sets out an experiment to investigate double slit interference. This is young, right? Double slit. The student uses light of single wavelength from a laser to illuminate a double slit so that pattern of interference fringes is observed on the screen. The student finds that the fringes are very close together. What could the student decrease in order to increase the separation of the fringes on the screen? So when you see the word double slit interference, this is definitely the only equation that you can use. Lambda is the wavelength. A in this case, okay, I just sub in. A is R. X is the fringe separation. D is the distance between the double slit to the screen. In this case, I want to increase this fringe separation. So I put X as a subject, lambda Q over R. I want to decrease this. So I have to decrease the wavelength, decrease the Q or increase the R. Okay, let us see. The distance P, nothing to do with distance P, just ignore. The distance Q decrease. Could the student? Oh, I want to increase the separation. So sorry. Yeah, to increase the separation. I want to decrease something, but I want to increase the separation of the fringe. Okay, let us see. Erase this. I want to increase the separation. So sorry. How can I give so blur? So you have to be careful. These are all the careless mistake that could have occurred. Even me myself also make careless mistakes. So beware with this kind of careless mistake. Read carefully. You see, just now I skip reading. So that is why be careful, right? Decrease. Okay, I want to increase the separation of the fringe. That is why. Okay, if the separation of the fringe increases, the lambda must increase, Q must increase, but R has to decrease. So I have to decrease the separation R, right? So because the wavelength must be increased, the distance Q must be increased as well. So C is the answer. Number 32. What are the definitions of potential difference and EMF, electromotive force, in terms of energy transfer and the charge, right? So the definition of PD is the energy transfer, right? Okay, energy, okay, transfer per unit charge, okay, to move, okay, to move charge from one point to another. That is the definition of PD. EMF is the energy transfer per unit charge, okay, to move the charge through a complete circuit. Right? So, in terms of the definitions, they are definitely different, but in terms of equation formula, they are the same. So, work over charge, right? Or energy transferred divided by charge. Now, question number 33. The diagram shows a network consisting of three resistors. What is the combined resistance of the network between terminal X and terminal Y? I want you to see this. 1.2 kilo ohm and 4.7 kilo ohm. They are being connected in parallel. When you see a parallel circuit, solve for parallel first. Right? Parallel. Okay. So for parallel circuit, so how do you solve for parallel? So it is, okay, 1 over 1.2 kilo ohm plus 1 over 4.7, and then you just invert it. Here you are supposed to get 3.16 ohm, right? And then this circuit can be simplified into this. X, this is 2.2 kilo ohm, and then this is 3.16 kilo ohm. Okay, this is Y. Can you see that? Okay. Once you get a series circuit, you just add it up. So total, R total is equal to 2.2 plus 3.16. Give you, right, no. 1 point, oh, this is 0.99, so sorry. Okay, this is not 3.16 is the answer. Okay, this is 0.9559. Okay, here is my answer. 0.956 kilo ohm. Okay, this is the kilo ohm. Kilo ohm. 0.956 kilo ohm. So you just add up 1.2 kilo ohm plus 0.956 kilo ohm. You should end up getting 3.15. Okay, kilo ohm or 3.2 kilo ohm. C is the answer. Right. Number 34, a resistor dissipated 25 watt of power when there is a potential difference PD of 4 volt across it. What is the resistance of the resistor? Right. So when the power is being given and you are asked to find the resistance, just use P equal to V squared over R. Easy. Right. R is equal to V squared over P. 4 squared divided by 25, you get the answer right away, 0.64 ohm. Right away, B. Now, 35, the diagram shows a cell with internal resistance connected in parallel with a fixed resistor and a variable resistor. Resistance of the variable resistor is decreased. Resistance decreases. What happens to the potential difference across the variable resistor and the current in the variable resistor? So could you see that when the resistance decreases, the current across the variable resistor will have to increase? You see that? And V is directly proportional to R, remember? So when the R decreases, the V would have to decrease. B is the answer. Now, 36. A radioactive source produces a beam of alpha particles in a vacuum. Average current caused by the alpha particle is 1.5 times 10 to the power negative 9 ampere. The beam is incident on a metal target. What is the average number of alpha particles hitting the metal target in the time of 3 seconds? Now, I want to do this. Do you still remember Q it? Q equal to IT. So I find the total number of charge first. Q is equal to 1.5 times 10 to the power negative 9 times 3 seconds. So here I got 4.5 times 10 to the power negative 9 coulomb. But the question doesn't want the total charge. Remember, total charge is depending on the number of electrons, or I mean number of alpha particles times the charge of alpha particle. The charge of alpha particle, alpha is 42He. This is the charge. The charge is 2E, remember. Okay, so the charge, okay, the total charge is given. Number of alpha particle, I don't know, but I know the charge of alpha particle, this is it. Now n is equal to 4.5 times 10 to the power negative 9 divided by 2 times 1.6 times 10 to the power negative 19. So the answer should be 1.4 times 10 to the power of 10. There's no unit for the number of alpha particles. It's just a number. Number 37, the charge carriers in a metal wire are free electrons. Which statement about the charge of each free electron is correct? Right? So the magnitude of the charge increases with the potential difference across the wire. Magnitude of the charge is constant, cannot increase. Right? Now, the magnitude of the charge is 0 unless there is a potential difference across the wire. Magnitude of the charge cannot be 0. Magnitude, the value of the charge. The value of the charge, magnitude of the charge. Let me write you. Magnitude of charge is fixed at 1.6 times 10 to the power negative 19 coulomb. So it cannot increase, it cannot decrease to 0. See, the sign and magnitude of the charge do not depend on the potential difference across the wire. Yes, the sign of the electron is negative. It does not depend whether potential difference is positive or negative. The sign of the charge is still negative, the sign of the electrons, because electrons are negatively charged. Magnitude is fixed at 1.6 times 10 to the power negative 19. Right? C is the answer. It does not depend. Right? Number 38, which flavors of quark have charge positive 2 over 3e? Remember, positive 2 over 3e, charm, yes. Strange, negative 1 over 3e. Top, yes, positive 2 over 3e. Bottom, negative 1 over 3e. So the answer is A. Just about memorization, yeah? Number 39, an unstable nucleus of an element decays by emitting an alpha particle or beta particle to become a nucleus of a different element. This nucleus is also unstable and emits an alpha or beta particle, beta negative. The process continues until an isotope of the original element is produced. What is the minimum possible number of these particles emitted? Isotopes means they have the same proton number. They have the same number of proton. So I just simply put 1, A, Z, X. Emit, okay, let's say emit 1 alpha particle. So what will happen here? A minus 4, Z minus 2. Then I get Y, right? So I want to get back the Z. Okay. I need I need to minus again, okay, but I want to add back the 2, so I minus 2 beta is negative 1, yeah. Okay, so I get A minus 4 Z minus 2Y, right? Okay, no, okay, I get another one. Okay, wait, yeah. So A minus 4 minus 0, I get A minus 4, Z minus 2 plus 2. So I get back the Z. This is Z. Can you see that in order to get back the isotope which share the same proton number, I need to at least, okay, how many beta, how many, okay, emit one particle and two beta, one alpha, two beta. So altogether, minimum three particles to be emitted in order for me to get back the isotope. The last question, number 40. A nucleus of carbon 10C decay, 10,6C, decays by beta emission to form a nucleus of boron 10,5B. So for this decay process, what is the change to a nucleon and what is the change in the quark composition of the nucleon? What is nucleon? Nucleon is proton and neutron, right? Could you see that one proton, right, is decaying to become a neutron? Find the neutron number, yeah? This is neutron number. A proton from 6 decay to become a neutron. So this is the decaying of proton to become a neutron. 1p proton decay to become a neutron, right? Beta negative electron plus antineutrino. Right, so proton is up, up, down. Neutron is down, down, up. Right, proton to become a neutron. Up quark change to a down quark. So B is the answer. So that is all about our discussion on the February-March 2024 AS Physics paper 1-2. If you need the solution, right, the file is attached in my description. Feel free to download the file, right? So I thank you so much for watching. And if you have any difficulties in understanding any parts of my explanation, right, feel free to comment below and let me know which are the topics or which is the topic that you find it hard in AS physics or any AS physics past year questions that you want me to discuss. Right? So I'll see you in my next video. Bye.